Hello. I was playing a bit with PathFinding and making a pre-visualization of how would be exiting from a puzzle and entering another, and I made this A-star implementation, but I used the the A-star implementation in the engine that allows you to, let me show you. You use the AStarGrid2D class, and let me see. This should be here for clarity. Okay. I made an object of this class, and you fill it when loading levels. I fill it with the information about which points are accessible and which points aren't. In this case, I go for all the walls in the levels. I set that specific point as solid. Then, using the input from the mouse, I get the beginning and end of a path, and I ask the code. Let me show you. Here in input, we calculate the drag begin and drag end points, and they are used in this function. And I was using different heuristics that the A-star algorithm provides. For example, this variable controls the distance heuristic. Let me show you. The Manhattan heuristic is a bit too regular. There are others. There is the Euclidean heuristic that takes the more intuitive distance between points to calculate each step. And perhaps I will make my own heuristic because these are too regular. Or perhaps I will add random obstacles to make the paths more meandering, but I don't know yet. What I wanted to do, instead of drawing using the, I'm currently using the grid map I showed yesterday to draw via code the points. I wanted, instead of drawing the points in the path, I wanted to draw the neighbors as walls, because the paths will be, in the end, will be an empty path surrounded by walls. So I will make, let me see, I will need I will need something like this, but here I should make a utilities class to let's see. I think we can have multiple lines in this kind of plus down, and this will be right. Okay, we need the 8 directions to make this. Let me see here. For each position, we are drawing currently the cell in that position, but instead of that, we need to do let me rename because these are the Conway directions. Conway directions. Let's see. Invalid operands. Yeah, because these are to the okay. So we will use the neighbor, but only if it's not in the path. Okay, I think it should work, but okay, yeah, nice. So we have path. It's also should check. Yeah, it should check that the neighbor is not in the walls. So let me see. We can check is point solid neighbor. I think that should work. Perfect. Okay, so we are seeing each. Let's use another grid element. Let's use another mesh. Let's use a box mesh, and let's give it, I think the material, yeah, the material is no, it's inside, yeah, cloth. Let's use the wall material. So when we draw, we will draw walls. Obviously, without the benefit of the procedural wall we had before, and this material is a bit, yeah, it's a bit wonky, but we'll fix it later, because I only want to check the different heuristics. Let me see, if I exit from here and end here. Yeah, one problem I anticipate is that if I want to make from an exit, I want to go upwards, for example, to here. The problem is that the player would not be able to fly and to this position. So perhaps the distance should not be symmetric. The distance used in the distance heuristic should not be symmetric, should allow only steps upwards from of 1 meter and steps downwards unlimited, because it's not a problem if I exit from here and want to go down, it's no problem for the player. But if I want to exit from here and go up, it could be a problem. So I will think about that. And also I wanted to add some random, let's see, this heuristic was the two regular one. Octile. Yeah, this is nicer, perhaps for the upward paths, but it's not too regular. Okay, I think I will use the, let's see, the cherry shape one. It's a bit like here somewhat similar. Yeah, perhaps I will use simply the Euclidean distance. That is the most intuitive for me. But with let's try it now. Let's see if we, at the moment of drawing the path, we check. We must we must set the heuristic before before getting the path. Okay. Let's add let's do 5 extra steps. Let's see. Random index and range from 1. This is inclusive, I think. Run range returns a random floating point from I need the run I range. And I range within from to inclusive. Okay. I don't want count -1. This is an int. Count. Count is another. It's a function that counts the occurrences of. Okay, I don't want the last element, so I will make this, and we will set point solid path random index and calculate again. Found. I think let's add only 3. because this could be catastrophic sometimes. Okay, we are getting an error. Why? Let's see. Draw path. Get index 1. Because, yeah, obviously. Let's if then path greater or equal to 3. Yeah, because the indexes are index 0 out of bounds. This is counter pose, container pose. No, I draw path. We have random index 0. Why? This is the debugger is very good, but yeah, obviously we must break if the path. So I think this should work. Wow. This is a bit. This is because. Yeah, this is because we are using auxiliary solid points here. So we will make temporary a temporary array of solid points and remove them. Array points, an array of set to E, and we'll add we'll add it, and after drawing the segment, or after computing the path, we will set point solid false. Okay, this will simulate a nice randomic. There are too few. Let's add a bit more. And let's see. Range 10. It's interesting. It's a bit more meandering, but perhaps too much. What happens if we use this in addition with the more stable distance? Yeah, it's a bit more controllable perhaps, because this is adding on the fly obstacles to the path. But I'm not sure. I will try other. It's very. I wonder how performant is the grid map in the sense of let's see the monitors FPS. Yeah, I don't think it's affecting too much, but when we have more points, perhaps it's let's add 30 random obstacles. Let's see. Yeah, it's a bit too random. Let's try the Manhattan distance. It's interesting. Yeah, I think it's a bit a mixture of control and chaos, because the chaos represents the random obstacles perhaps represent different materials in the soil, so the people that excavated these catacombs encountered different obstacles. Yeah, I think I will use this combination, or perhaps the octile one. Let's see. Yeah, I don't know. Obviously, this will require more testing, but for now, I think it's good progress. I hope you liked this. Thanks for watching. Don't forget to like the video and share it with people that could learn from this or enjoy it. Thanks.